Okay, so the definite integral. Now, the first parts of the slide here, it's all about a comparison of the definite and the indefinite and what's the essence or the significance of the definite integral. So let's look into it. So for the learning objective, at the end of the topic here, you, my dear students, should be able to evaluate the definite integral. When we evaluate a definite integral, we will have a definite answer. It's not an equation, but rather it's a value, like a real value. Okay? Now, let's review. So we know that integration is also known as anti-differentiation, and it is the reverse of differentiation, or one way of knowing whether we have integrated a particular integral is when we differentiate it and it goes back to the original expression that was provided for us. So if, let's say, for example, x cubed is differentiated, it will give you 3x squared. If it's integrated, it will go back to x cubed. It's the same thing with x to the fourth minus 2x plus 3. When differentiated, will be 4x cubed minus 2. If this one is integrated, it will give you this one. However, if you notice, you don't have that constant here, which is 3. So we will address that problem later. Okay, so if you differentiate your 4 sine 2x, that would be 8 cosine of 2x. And if this one is integrated, you need the 2 here, so that would be 4 sine of 2x. Now, let's move on. But it is not quite as simple as that particular contrasting of how your integral answers the differential and how the differential rejects the answer for the integral, vice versa. So if you have this will be your derivative. If you have this will be your derivative. If you have this will also be your derivative. If you notice, they have the same derivatives, but they came from different functions. So something weird, and the answers are all the same, which should not be. So even though the original functions were different, our answer are all the same, or our answers are all the same. And if we will integrate those, it will not go back to the original. So if you will integrate this, you will not have a 5. If you will integrate this, you will not have a 3. If you will integrate this, you will not have a negative 7.5. So to address the problem of the ambiguity, not so clear values, especially with the constant, when we integrate already the derivative of the function, we have to be very able to distinguish what we call an indefinite integral from a definite integral. So this has big implications when we want to go the other way around, that is to integrate the expression 2x. So it has many integrals because of the c that you have here. So 3 answers having the same derivative. The derivative when integrated will have a limitless number of answers because of the c in here. So this is your what we call the indefinite integral, and this is what you have been studying the entire midterm, how to evaluate the indefinite integral. So the C tells you that this could be any constant. So it could take the place of the 5, the 3, and the negative 7.5. That way, the 2x which you have integrated would all be like equivalents of these functions. Okay, now, to address the problem of making things specific, we have now what we call the definite integral. So you have to account for the c's. So the original does not have the c's when integrated. So now we have placed in the c's, the constant of integration. But that does not make things specific still. So when I say of specific, this one is just an arbitrary constant that does not specify anything. This one is an arbitrary constant. This one is an arbitrary constant. So there's a need for us to specify things in integral calculus, especially when we do already the applications. So Leibniz, if you have heard of the guy, we have to be thankful of him, gave us what we call as the definite integral, equivalent to the summation of the products of the term f of x and delta x. Okay, so if you will take the summation of the product of f of x and delta x, starting with f of k1 until kn, that would also be the same as getting the integral of the function of x and evaluating it using the limits a and b. So this one is a definite integral because this time you have the appearance of the limit. So this dx is actually your equivalent delta x in here. Okay? So indefinite and definite, what's the difference? So indefinite integral will always finish with an arbitrary constant c, which does not specify the final value of the function. Definite integrals don't need this c anymore, and when evaluate yields a numerical or a definite value. The only difference with them, the indefinite and the definite integral, are the presence of the limits. The limits of integration, we call them the upper limit and the lower limit. They make the value of the integral when evaluated already specific. So in this case, wait class, I cannot move on. So in this case, this is your upper limit and that's your lower limit. And this is your definite integral, a very simple definite integral. So how do we evaluate a definite integral? So you could see that if your x squared is evaluated, that would be x cubed over 3 using power rule. And we don't write anymore plus c because we're going to process this one using the limits. So if you're going to process it using the upper limit 6, so your x cubed will be 6 raised to 3 over 3, having a value of 72. Now, if your x is 3, the lower limit, that would be 3 raised to 3, which is 27 over 3. That will give you a 9. So the value of this answer that you got will be subtracted. The value of the upper limit minus the value of the lower limits substituted to the answer of the integral will give you the specific value of the integral itself. So now your answer for the integral of x squared from 3 to 6 will be 63. So you did not answer x cubed over 3 plus c, but rather you answered a definite value. Now, the general rule then, if you're going to apply the limits on your definite integral would be this. It would be f of b, the function evaluated at the upper limit, minus f of a, the function evaluated at the lower limit. Very simple. Get the integral of the function and evaluate the function on its provided upper and lower limits. Get the difference, that would be the value of your integral. Okay? Now, let's try another one. So let's say, for example, you're given this 6x squared minus x plus 1. That would be 2x cubed for this. That would be x squared over 2 for this. And that would be x. If we're going to evaluate using the limits 5 and 2, if we substitute first the upper limit 5, so the x will be changed to 5. So this would be 5 cubed, that would be 5 squared, and this would be 5. The answer is 242 and a half, or 242.5. If you substitute the lower limit 2, so the x here will be 2, same thing with the x here, and same thing with the x here. The answer is 16, giving you the difference of the value of the function at the upper limit minus the value of the function at the lower limit equal to 226 and 1/2, or 226.5. This itself tells you that the answer to a definite integral is a specific value because you have already the presence of the limits. And you don't have anymore the arbitrary constant c, which in the case of the indefinite integral will only have limitless values because it's arbitrary. Its value, meaning, could be anything as long as it's a real number. Now, since you know already how to process definite integrals, it's important that you know the properties associated with it. And there are 10 properties of definite integral. Number 1 is the existence property. Now, what is this? If f is continuous on the closed interval AB, meaning if you're going to plot the function starting from A, ending with B as your x value or as your independent variable value, then f will be integrable there. So if it's continuous, if the function is graphed and there's no discontinuity in the graph, then it is expected that you will have an integral for that function. That is, if you will process this one, you will have a value that is existing, a real value. That's according to the first property. The graph of a continuous function will be a value that is existing. Okay, it will be integrable and it will be existing. Property number 2. If you have integrated a constant, it's like you set aside the constant and you process the integral of the dx, which is simply the x. So the integral of a constant is that constant times the difference of the limits. Why are you saying, or why are we saying that it's just simply the constant times the difference of the limit? It's because class you only have a dx here. When you integrate that, that would simply be an x. If you substitute the limits, that would be simply b minus a. So any constant for that matter, when integrated by a definite integral or is processed as a definite integral, will have an answer equal to that constant times the difference of the limits that were provided. If c then is equal to 1, then it would be a pure case of the difference of the limits. If c is equal to 0 class, if the constant is 0, the integral of a constant that is 0 is always a 0. What does this mean? No matter what your limit here is, as long as the constant that you're integrating is 0, automatic, the answer of that integral is 0. For any real number which is integrated on a definite integral which has the same limits, you see this, they have the same limits, a and a. So an integral having the same lower and upper limit will have a value which is equal to 0. Of course, because you only have these two being subtracted from each other. So the value is a 0. A constant that is that is used as the limits of integration, same lower and upper limit, will yield an integral which is 0. Property number 3. If on the interval AB, the integral of the function of x from a to b exists, meaning it has a value, then the integral of the function from b to a, what happens here, class, is you interchange the lower limit and the upper limit. So the value of the integral of b to a will be the negative of the original, or interchanging the lower and the upper limits of your definite integral makes the value of that integral negative, the negative of the original. So if this is the original, you interchange the limits, then the answer will be the negative of the answer of this. Okay? Now, property number 4, if the function of x is integrated from a to b, and it could be negative, hence, if used to find the area of the region below a curve of the function of x, the area of that particular curve below the axis, that is why it's negative, should be the absolute value. Okay, this may be quite hard to understand since we have not yet reached the topic of the plane areas, which is one of the many applications of integral calculus. But this is just what you're going to understand, class. When you are processing a definite integral with the end goal of determining the area of a curve and an axis, or the area between two curves, if your answer is negative, it is not actually the actual area that you are solving, but rather it's the absolute value of that area. However, there's a big danger in here when we speak of that automatic if your answer is negative for a definite integral in which you are defining the area or determining the area. If it's negative, you just make it positive. Class, this is only the case when your curve, so again, let's specify. This is only the case when the curve is below the axis in which you're going to determine the area of such a curve. In cases wherein this is not so, hindi ni siya amo, pero ang nasolve mo nga area is negative, it is not as simple as making the area positive. You will learn it when we go to that topic. But this is just, okay, again, this is just for the case that is specified here. If the function or if the integral of the function could be negative, and if it is used to find the area of the region below a curve, so below a curve, that particular negative value you can turn to positive because it's below the curve. Okay, the region, the area is below the curve. However, it's not always the case. Okay, you will learn about the details of determining the areas between curves, between a curve and an axis when we go to that particular topic. Note, there's a note here. If you obtain a negative value for an area, don't just take the absolute value of such a number. Don't just take the positive value of such a number. It's only in the case that is stated here. Okay? Now, number 5. If f is continuous on a closed interval, and if c is in the middle of a and b, meaning the value of c is between a and b, then f is integrable on ac and cb as well. What does this mean? For example, class, you integrated from 1 to 10. And then somewhere in the middle of 1 of 10, you know that you can have 7, you can have 5, you can have 6. If you're going to break down the original integral that was evaluated from 1 to 10 to 1 to 5, and then 5 to 10, your answer would still be the same. It is illustrated here. This is only true when your integral is continuous, meaning, or rather, not integral, when your function is continuous. Meaning, your function will not have any discontinuity, wala siya utod kung i-graph siya sa sina nga interval. If there are discontinuities, of course, this will not be applicable. So, for example, this function here is integrated from 1 to 10. You can split it actually. You can split it from 1 to 5 and then 5 to 10. The answer of this one integral is just equivalent to these two. Or it could be like 1 to 7 and this one is 7 to 10. Or this could be 1 to 3 and this is 3 to 10. Basta wala lang sang discontinuity ang graph sang function on the limits provided. Okay? Now, 6. If your function is multiplied to a constant, when you integrate it, just like the differentiation, you set aside the constant. You write it outside your integral sign and just simply process the integral of your given function. Process it and then substitute your limits. After you are done processing this one, you can multiply your final answer by the constant which you have set aside. Okay, next, 7. If you have two functions, f of x plus g of x, and then you have it integrated from a to b. By the way, class, there's a double typing error here. There should not be a function of x here. You can process it first as f of x evaluated from a to b, and g of x evaluated from a to b. Na double type ko diri, class. This should not be f of x here. This should only be f of x plus g of x. So this tells you that if, for example, this is tangent x and this is cosine x, what you can do is process first the integral of tangent x and substitute your limits. Then you add to that the integral of the next function, just like what's done here. And take the sum again of your final answers. Now, number 8. If f is integrable on the closed interval AB, and if f is equal or greater than 0, then the integral of the function of x dx evaluated on that particular closed integral will be also greater than 0. If f is integrable on AB, closed interval AB, and f of x is greater than 0, then f of x dx is greater or equal to 0. Kulang siya equal diri class. Okay? If f of x are integrable on AB, we're now on the ninth, and for every x in AB, f of x is less than g of x, f of x is less than g of x, then the integral of f of x evaluated from a to b is of course expected to be either equal to or less than also the integral of g of x evaluated from a to b. This is very self-explanatory. In the first place, f of x here is already less than g of x or equal to it. It follows if you're going to integrate these two functions on the same limits, you will have also the same relationship. Their integrals would either be equal to also or less than each other. Now, number 10, the last property. The mean value theorem, that is, what is this mean value theorem? You have if f is continuous on the interval AB, then there exists a number c in AB, meaning somewhere in between AB, such that the function of c, this particular c value in between AB, times the value of b minus a is equal to the integral of the function evaluated at a, b, or evaluated on the limits a to b. So remember, c is in the middle of these two intervals. So if c is in the middle of these two intervals, if the function first is evaluated at c, meaning isubstitute mo si c sa values ng function, and i-multiply mo siya sa difference ng inyong limits ng a and b, that is the same as or equal to the definite value of the integral of that function evaluated from a to b. That's the mean value theorem. So the same value for both. For now, you may not, you may not have a specific application on this, but I think if I'm not mistaken, process control or in your controls in the case of the ECE, and I think ang COE, they have their controls, I'm not so sure, or in your advanced math, you will again encounter the mean value theorem. So we have three properties for the definite integral, but in terms of the definite integral, it's just easy. It's easy if you know how to evaluate the indefinite integral. The indefinite integral. Now, in your case, it's even super easy because you have your calculators that can evaluate it for you. Meaning, your calculators can evaluate a definite integral as long as you have the limits. So when we will have a quiz later, the procedure on determining the value of a definite integral has to be really shown because your calculators can already process the value of this. My calculator, which is even very old, can also process definite integrals which has limits. So it's important that you know how to process your given function even if you don't have your calculators doing it for you. Okay? Now, these are the properties. Do you have any questions? Any question, class, regarding the definite integral? Or I'd like to go back to properties if you have any questions. Most of the properties are really very self-explanatory. Or shall I say, you need not know or you need not be an engineer to be for you to be able to understand it. Why? Because it's just constants and integrals and the concepts that are being discussed in here. So take note of the terms continuous, meaning if you're going to graph the function on the interval that is stated, your function will not have a point of discontinuity. If it does not have a point of discontinuity, then the integral of such a function exists, or it is said to be integrable. This one is a constant, so this is self-explanatory. Same thing with this. Same thing with this. This is important. Interchanging the limits of an integral makes the value of the original integral its negative. This one, in terms of areas, when it's below the region, or when the area that we're determining is below the curve, the region is below the curve, at times the value of the area that you have is negative. You have to take the positive of that. But this is not always the case, meaning this will not work for all cases wherein you have determined or you have calculated the area and it's negative. This one is also very fundamental in integral class. When you have an original limit and you want to slice your function using an interval which is in between these limits or somewhere in between these limits, that would be it would be the same as evaluating the function piece by piece using that particular middle value. So A to C, if we have C in between A and B, and again, since C is the upper limit here, it becomes the lower limit here, C to B. This one is very simple. That's for a constant, and this one is for a sum, and this one for functions greater and equal to 0, and for functions that are less than or equal to, even if greater than, this would also work. Okay, it's already a given that the function f of x is less than or equal to g of x. It follows that if we are to integrate them on the same integral, the relationship would still hold true. That's it. That is, it's either also equal to or less than for the two functions. Okay, no more questions, guys. I'm waiting for questions should you have any questions. As for exercises, I already posted in Canvas your problem set number 7, if I'm not mistaken, but that's still due on April. For you to practice solving, you can practice solving on definite integrals, and it would still be substituted rather submitted per group, because that's a problem set that is to be processed by groups. Okay. Any question, Nan? Okay. So if there aren't any question here, I'd like to proceed to stop share. I'd like to proceed to a new topic, the improper integral, because it's quite long. And I'm not sure if next week we'll be able to see each other on Wednesday again, because it's Holy Week. If it's not COVID, if it's Holy Week, we only meet half day. So it's important that I better now discuss the things that I can discuss, because I do not know the number of days wherein classes will be disrupted. So we go to improper integrals class, okay? Allow me to just proceed. Anyway, we'll just take it slowly as long as we make use of the time. Feel free to butt in or interrupt me whenever you think you cannot follow through, okay? Okay, let me share again. The improper integral. An improper integral class is also a definite integral. So that is why we started our end term with the topic on the definite integral. An improper integral also has limits. Okay? So we'll proceed. So as to the learning objective for this set of slides, you are to know that the definite integrals will have limits, which is infinite. So you know what infinite is. And that the improper integral is also a definite integral in which the function has a discontinuity. So meaning on the interval designated or on the interval placed on your integral, your function when plotted will have a point of discontinuity. In our vernacular language, utod siya, may nautod siya nga part on the interval nga i-evaluate mo ang integral. Kung i-graph mo siya, may utod siya. So kung may utod siya, it means that your integral or your definite integral specifically is also an improper integral. It could also be improper if one of the limits of integration is infinity. So this is the thing that you're going to be able to do at the end of the topic. And you should be able to distinguish convergent and divergent integrals. And by the way, for those who are present this afternoon, I gave a pre-assessment quiz. It's not graded. It's ungraded, but nonetheless, you have to answer it until, I think I placed until 11:59 today. So please answer that one. That way I would know whether you have an idea of the things that we're going to discuss. Okay? But it's not graded. It will not be part of your grade for NTEM. It's just a pre-assessment quiz. Now, these are the things that you need to be able to do when we're done with the topic of improper integral. Process improper integrals which have one of its limit as infinite or which has an infinite discontinuity. And then recognize or distinguish convergent and divergent integrals. Now, in defining a definite integral, this is the definite integral, we dealt with the function f defined on a finite interval. When we speak of finite class, a and b are real numbers. So that's what it means when we say finite. And we assume that this particular, excuse me, definite integral has an infinite discontinuity, and we assume that f does not have an infinite discontinuity. Okay, if f does not have a discontinuity on the limits of integration a to b or on the intervals a to b, then this particular integral is said to be existing. What happens if the or if any of the limits here is infinite or if the function has a discontinuity? That's something that we will study also this afternoon. So in this topic, we extend the concept of the definite integral to the cases wherein the interval is infinite or the limits of integration is infinite or one of the limits of integration is infinite, and if f has an infinite discontinuity. So duha lang man siya ka scenario, class. There are only two possible scenarios wherein your definite integral is an improper integral. One is if its limit of integration, if one of the limits of its integration is infinite, and the other one if even if the limits of integration is not infinite, but if you're going to plot the function, there's a discontinuity, or shall we say the value of the function cease to exist, wala na siya naga-exist, then the particular definite integral is also what we call as an improper integral. So this is how we classify improper integrals. The limits of integration has infinity. So in this case, the upper limit is infinite. And the second one, this one, you have a discontinuous function on this particular limit. Now, I'd like to annotate here para diretsyon na lang. Why is it that this one, this function is said to be discontinuous on the interval 1 and -1? So I will show to you. Okay, I'll write it here para isa na lang ka-discuss. If you will evaluate this class, this is the integral of x raised to -2. If you're going to evaluate it, that would be -1 over x, right? The integral of x raised to -2 is x raised to -1 over -1. So this is your answer. And your limit is -1 to 1. Look what happens if you substitute the 1 and the -1. So I'll place the negative here. and I will place the 1 here. So you have 1 over 1 minus 1 over negative 1. Okay? Now, look. If you're going to look at it, this will be negative 1 plus 1, right? And it seems like this is plus because negative. And it seems like your answer is negative 2. You may say, Miss, there's nothing wrong with this. My answer is a real number. Yes, that is why we call this also a definite integral. But it says here, it's a discontinuous integral, the integrands with vertical asymptotes. When you plot this one class, when you plot the function 1 over x squared, and on the limits negative 1 to 1, it will have a point of discontinuity. That is why we have to be very careful because this may look like an ordinary definite integral. O kung sulbon mo siya, yung may value gid siya. So you will say, this is a definite integral. But actually, specifically, it's an improper integral because your function has a discontinuity. Okay, I will show to you what is discontinuity in terms of the function. So mag-clear before I will proceed to the next slide. Okay, I'll go to the whiteboard so to show to you what is it. We're going to plot, this is x and this is y. And our function of x is 1 over x squared. Okay, now in this particular x and y axis, I will place here negative 1. I will place here 1. Okay? I will plot the original function. You may wonder, where did you get the 1 over x squared, miss? I'll go back to the slide so you would understand. It's important that you understand this. This is your original function, okay? When we evaluate its limits a while ago, it seems like there's no problem because our answer is negative 2. So you may say this is a proper integral. This is not an improper integral. But look, this has, as I said, a point of discontinuity on the interval negative 1 to 1. So that's what I'm going to show to you now. Okay, I'll go to the whiteboard. Okay, this is our whiteboard. So I will plot the value of f of x for values of x. So if this is my x, this is my corresponding y of x. I'll start with negative 1. If my x is negative 1, you substitute it here, that would be 1 over negative 1 squared. Negative 1 squared is 1, so this is still 1. 1 over 1 is 1. Okay? Now, the next value that we'll have is 0 because it's in between negative 1 and we have 1, so this is 0. So we need to plot our function from negative 1 to 1. If you divide 1 over 0, your answer is infinite, right? Whereas if you substitute 1 in here, your answer is also 1. What happens here is that, I'd like to show to you, this one is a point of discontinuity. Whenever the function itself has a value which is infinite, you cannot have it plotted. Hindi mo na siya ma-plot class. Paano mo na siya i-plot karon? For it to be clearer pagid, I will assign a value between negative 1 and 0. So, let's say negative 0.5. I place here negative 0.5. Okay? So, you would know the behavior. Can you please give me the answer for 1 over negative 0.5 squared? So, that would be 0.5 squared. So, the answer is 4, right? 4. Then, you will have here, dibutan ko na lang ding negative 1 and you have 1. And you have 0, which is infinite. And you have here positive 0.5. Your answer is still 4. And then you have 1, which is 1. So, based on our slide says that the line x equal to 1 This one, this is the line equal to x, or the line x equal to 0, our y-axis. Your y-axis is the line x equal to 0, is the vertical asymptote of this particular curve. Why? Because it's going to approach this particular line infinitely. What do you mean by that, Miss? So I will use a different color here, a contrasting color, so you will see. So from the left class here, since the value of negative 0.5, somewhere here in the middle is 4. So let's say this is 1, 2, 3, 4. Somewhere here, the value of your function, something like this, it's going to extend there infinitely. On this side, if it's positive 0.5, it's the same thing. But the thing is, your function is utod. It's said to be discontinuous. Why? How do you know, Miss, that it's discontinuous? Because the utod do, tani, hindi siya mautod. It's going to approach this line. It's asymptotic to this line. It's going to approach this line infinitely. It's like, if you're going to draw a line, class, padakuon ko para makita nyo. And this is a negative 1 and this is negative 0.5. Ang gwa niya sina, use a different color para maintindihan nyo. Halin di siya o, nan, maamo na siya o nan, i-approach siya lang gini nga line pero hindi gina siya mag-cross. Palapit nga palapit pero hindi gina siya mag-cross. It's the same thing in here. It's 1 and you have here 0.5. It would also be approaching. That is why we call it the vertical asymptote. I think it was also discussed in your differential calculus. So your curve is said to be your function, not your curve. The curve of your function is having this discontinuity. So, if you would be asked in a simple question, I will go back to our slide. Let's say you would be asked in a simple question, is your function an improper, is your integral an improper integral? You will, I'm sure, you will always be tempted to say it's just a definite integral. It's not an improper integral because take kung imo siya answeran, ang answer gani real number. But the thing is, there is this. In this particular set interval, your function is discontinuous. Somewhere in between, utod ang graphs ng function. So then, this integral, though it does not have an infinite limit, is said to be improper. So, duha man na siya kaklase. It's either you will have a limit here, you will have a limit here na infinite, negative, and this one is positive, or you can have this discontinuity. The hardest to decipher or understand is this one, being an improper integral, because you won't know it unless you plot it or unless you check the value of the function. You check the value of the function, whether it's existing for all values in this closed interval. Because if we write this class in an interval form, it's written like that. So meaning all values in here, it is expected that for your function to be not improper integral, it will not have any discontinuity. In our case, at 0 in between negative 1 and 1, as shown to you here, your function has a point of discontinuity, this one. So it is an improper integral. Okay? Just for you to have a clear mindset on when can a definite integral be improper. Now, do you have any question for now? So this will be the next set of slides that we're going to discuss next week, the improper integral slide, and probably we can proceed with Simpson's rule and trapezoidal rule. If you have time, please read them in advance. That way we can go on smoothly. Okay? I will stop sharing. Do you have any questions, class, regarding the topic that we have discussed this afternoon? You're not even half of the class is present. Maybe nakapoy na ang mga estudyante kay tunga pa lang tamay tunga pa tanga taklaron. Any question? None?
None, Miss.
Sige, sige. So it's 5 minutes before that time. I don't want to hold you up here. So enjoy the Animal Olympics days starting Wednesday, and we'll hear each other again on Monday next week. Hey class, bye for now. Have
Thank you, ma'am.
enjoy your Animal Olympics.
Bye,
Thank you,
Miss.
ma'am.
Bye bye.
Bye, Miss.
Bye.